let's so see in specifically dictionaries. As I said, the dictionaries do not preserve the order, but if you are interested in preservation of the order for which you inserted the element, you can use order dict. And if you want some kind of sorted dictionary, you have a data structure called sorted dict from the package data structures. Both of these one behave as are subtypes of abstract dict, so all we say here about dictionary will apply also to this data structure. So we already saw arrays, tuples, and numbered tuples. Maybe it is a time to put a little bit on order. So on one side, you can have data structure that are mutable. You can change the elements, are somehow less efficient in terms of computational speed, but and size, but they are more flexible. On the other side, you have immutable containers that are really efficient, but after you created them, you can no longer change them. And on another dimension, you can use just the position to indicate one element of the container. So in case of using positions and mutables, you have the standard arrays. If you want a version of arrays that is immutable, but still you access with positions, you have tuples. And now you can see that as arrays stay on tuples, here we have the dictionaries that are somehow like named tuples that we just saw, but that are mutable. So our dictionaries are mutable structures that for which you use key to access them. And this is the type of a dictionary, so it will be dict, and then it will have two different types, one for the key and one for the values. Differently from arrays and tuples, where you can use just squared or enclosed parentheses, for dictionary you need to specify dict. And as for other structure, you can just use dict, or you can specify the types of the key and the values. In this case, will be more efficient. And if this create an empty dictionary, if you want, you can fill it already with data, adding pairs of key and value with surrounded by divided by comma. So to retrieve an element, as you may guess, you can use the square brackets and the key, and we retrieve the value associated to the key. Notice that a problem here, if the key that you are looking up is not present, like in this case, you will get an error. So what can you do if you are not sure if a key is present in the dictionary? Well, you can first say ASCII here, using this method here, and then look up. But a more direct way is to get just using get. And the nice things of using this function is that we provide a default value if the key is not present. So if the key is present, of course, it will return its value. But if the key is not present, you can specify which is the value that you want. Notice that, so here D is not present. You can add a pair of key and the value by simply using the same syntax as to retrieve the element. So you use squared brackets and you say which element you want to add. And you can delete, you can ask if has key, you can even ask if there is a particular pair of key and value in my dict with using in. And something we may not have seen is this syntax here. So this syntax here, if I say type I, tape off, we can see that really this is called a pair, is an object called a pair, and is specified by the first and the second element of the pair. We can have several ways to convert an array in dictionary. We can use map, that is a function that we will see in details in another segment. So here we have a vector of key, a vector of values, and here we are specifying that each element of both of them will form our dictionary. Actually, this add to a dictionary, so this will not work to create a new dictionary, but you can add elements to an already existing dictionary using this syntax. Otherwise, another way is, if you have want to create a new dictionary, is to use list comprehension using this syntax with zip, but as for we did for named tuples, get one element at a time from these two vectors of keys and values, and we create inside the constructor of the dictionary, and this will create a new dictionary. We can retrieve the keys and values like for named tuples, and with the note that these will remain iterators, and if you want to have vectors, we need to collect the iterator. In general, we can iterate a dictionary using key and v using this syntax. So we specify in a parenthesis the two elements that we want, and we can loop over the two, and this is the output. The last data collection that we see is the sets that take the type of the element inside, and the sets are well, very close to their mathematical meaning. They are a collection of unordered unique values. So with sets we say what is inside, but we don't say where, on which position it is, and they are mutable. So as for dictionary, we need to specify set as keyword or set with the type, and we can add directly the content in the constructor by providing a vector of elements. And you can see here that even if we put twice the number 2, the set that we have as results has only one element of 2, and you can see also that the order is not the one that we provide. We can add element to the set with push, with the exclamation mark. Do you remember function with exclamation mark by convention change the first argument? So here the first argument is the set that we want to change. We change it, we mutate because we add one element, and the same for delete. And sets are used for what sets are used in maths. So if you create another set, we can see here that we can have intersection, union, or set diff, or other as well typical set operations.